Oppenheimer once said something that should terrify you. There are children playing in the streets who could solve some of my top problems in physics because they have modes of sensory perception that I lost long ago. Think about that for a second. One of the smartest physicists who ever lived, admitting that there are things children can understand that he can't anymore. Not because he forgot something, but because growing up, becoming educated, learning physics actually made him less able to perceive certain truths about reality. And if you're the kind of person who wants to understand the real limits of human knowledge and why even geniuses hit walls they can never break through, hit subscribe, because what I'm about to show you will change everything you think you know about understanding the universe. What Oppenheimer discovered wasn't just a limit in physics. It was a limit in us, in our ability to comprehend what's actually real. And the deeper he went into quantum mechanics and relativity and nuclear physics, the more he realized we're trapped inside a prison of perception that we can never escape. Let me show you what he found. Here's what nobody tells you about physics, and it's the most important thing to understand. Every equation, every theory, every model we have is not describing reality. It's describing our interaction with reality. And there's a massive difference between those two things. When you learn physics in school, they show you Newton's laws. Force equals mass times acceleration. Energy is conserved. For every action, there's an equal and opposite reaction. And these laws work incredibly well for everyday stuff. You can calculate how fast a ball falls, how hard a car hits a wall, how much fuel a rocket needs. The math works. The predictions match reality. And you think, okay, so we understand how motion works. Except we don't. Not really. Because Newton's laws completely break down when you go really fast or really small or really massive. At high speeds, Einstein's relativity takes over and suddenly mass increases with velocity and time slows down and space contracts and nothing makes intuitive sense anymore. At tiny scales, quantum mechanics takes over, and particles are waves, and waves are particles, and nothing has a definite position until you measure it, and measuring changes what you're measuring. And here's the disturbing part. Both theories work. Relativity makes incredibly accurate predictions about gravity and space-time and the universe at large scales. Quantum mechanics makes stupidly accurate predictions about atoms and particles and forces at small scales. But they contradict each other. They give different answers about how reality works at a fundamental level. And nobody, not Einstein, not Oppenheimer, not any physicist alive today, has been able to unify them into one coherent picture. We've hit a wall, a limit in our ability to understand what's actually happening. And Oppenheimer realized this wall isn't temporary. It might be permanent, built into the structure of how human minds interact with reality. Picture yourself trying to explain color to someone who's been blind since birth. You can use analogies. Red is like warmth. Blue is like coolness. Yellow is bright and cheerful. But no matter how good your descriptions are, the person will never truly understand what you're experiencing when you see red, because understanding color requires the sensory apparatus to perceive it. Without eyes that detect electromagnetic radiation in the 400 to 700 nanometer wavelength range, without a visual cortex that processes those signals, color doesn't exist as an experience. It's just wavelengths, numbers, abstract data. Now apply that same logic to physics. Our brains evolved to survive on the African savanna, to track animals, avoid predators, find food, recognize faces, navigate three-dimensional space at human scales and human speeds. We're really good at that. But we never needed to understand quantum superposition or curved spacetime or 11-dimensional string theory to survive and reproduce. So our brains aren't wired for it. When you try to visualize an electron existing in multiple places simultaneously, until observed, your brain rebels. It doesn't compute. When you try to imagine four-dimensional space-time where time is a dimension like width and height and depth, you can manipulate the math, but you can't actually picture it. When physicists talk about particles being excitations in quantum fields that permeate all of space, you can learn the equations, but you can't truly perceive what that means at a gut level. And Oppenheimer understood this. He realized that the deeper physics goes, the more it diverges from anything humans can actually comprehend in an intuitive sensory way. We're using mathematics as a crutch, a tool that extends beyond our perceptual limits. The math works, the predictions are accurate, but we don't understand what the math is describing in any deep, meaningful sense. We're like blind people using sonar to map a room. We can build an accurate map, we can navigate successfully, but we're not seeing. We're inferring. And there might be aspects of the room, aspects of reality, that our sonar just can't detect no matter how good it gets. Let me show you exactly where Oppenheimer hit this wall and why it shook him. In the 1920s and 30s, he was working on quantum mechanics, specifically on how particles and antiparticles interact, electrons and positrons, matter and antimatter, and the math was giving him answers that made no sense. According to the equations, the vacuum, empty space, isn't empty. It's filled with infinite energy. Virtual particles constantly popping in and out of existence, electrons appearing with their antimatter twins, existing for impossibly brief moments before annihilating. And when you try to calculate how much energy is in the vacuum, the math gives you infinity, literally infinite energy density, which is obviously wrong because if space had infinite energy density, the universe wouldn't exist. Everything would be ripped apart instantly. So physicists do something called renormalization. They basically subtract infinity from infinity in a very careful mathematical way to get finite answers that match experiments. And it works. The predictions are the most accurate in all of science. Quantum electrodynamics predicts the magnetic moment of the electron to 11 decimal places, and it matches experiments perfectly. But nobody understands why this mathematical trick works. We're subtracting infinities. That shouldn't give you meaningful answers. It's like saying infinity minus infinity equals 3.7, and somehow that's correct. Oppenheimer knew the math worked, but he also knew we don't understand what it means. We don't know what the vacuum actually is. We don't know if virtual particles are real or just mathematical artifacts. We don't know why infinity minus infinity gives us the right answer. We've hit a limit in comprehension. The universe is doing something our brains can't grasp, and the math is our only guide through territory we can't actually perceive or understand. While you're thinking about that, drop a comment and tell me what city or country you're watching from, because I love seeing how far these ideas reach and where in the world people are who want to confront the actual limits of human understanding instead of pretending we know more than we do. And here's where it gets even more disturbing. Oppenheimer also worked on quantum measurement, the observer effect. And this is where physics completely abandons common sense. Before you measure a quantum particle, it exists in superposition, multiple states simultaneously. An electron can be spinning up and spinning down at the same time. A photon can go through two slits at once. The particle is described by a wave function that contains all possibilities. And when you measure it, the wave function collapses. You get one definite result. Spin up or spin down. Through slit 1 or slit 2. But here's the problem. What counts as a measurement? Does it require a conscious observer? Does the particle know it's being watched? Or is measurement just any interaction that leaves a record? Oppenheimer and the other physicists argued about this for decades. They never reached agreement, because the math doesn't tell you. Quantum mechanics gives you rules for calculating probabilities, but it doesn't explain what's physically happening when wave functions collapse. It doesn't tell you what observation means, and different interpretations give wildly different pictures of reality. In the Copenhagen interpretation, the wave function is just information, and collapse is updating your knowledge. In the many worlds interpretation, the wave function never collapses, and every measurement splits reality into parallel universes where each outcome happens. In pilot wave theory, particles always have definite positions guided by hidden waves we can't detect. All these interpretations make the same predictions. They all match experiments perfectly, but they describe completely different realities. And there's no way to test which one is true because they're all empirically identical. We've hit a wall, a fundamental limit where physics can't tell us what's real. Only what we'll observe. And Oppenheimer realized this means there are questions about reality that science might never answer. Not because we need better experiments, but because the questions might not have objective answers independent of interpretation. This applies to you in ways you probably never considered. Your brain right now is made of atoms following quantum mechanical rules. Neurons firing. Synapses releasing neurotransmitters. Ion channels opening and closing. And at the quantum level, all of this involves superposition and uncertainty and wave function collapse. Some scientists think consciousness itself might emerge from quantum processes. That your subjective experience, your sense of being you, might depend on quantum coherence in microtubules inside your neurons. Others think that's nonsense and consciousness is purely classical. Electrical signals in networks of cells. No quantum weirdness required. And here's the thing. We don't know. We can't know with our current physics, because we don't understand consciousness, and we don't fully understand how quantum mechanics interfaces with the macroscopic world of brains and bodies. You're experiencing something right now. Qualia. The redness of red. The pain of pain. The taste of coffee. The feeling of being you. And nobody knows how atoms and molecules arranged in certain patterns create that inner experience. It's called the hard problem of consciousness, and it might be unsolvable. Not because we're not smart enough, but because the problem might require a type of understanding that human brains fundamentally can't achieve. Like asking a calculator to feel emotion. The hardware isn't capable of that type of operation. Oppenheimer understood this. He read extensively in philosophy and Eastern religion. He studied the Upanishads and the Bhagavad Gita. And he became convinced that there are modes of knowing that go beyond scientific materialism. That rationality and mathematics, as powerful as they are, have limits. And beyond those limits, you need different tools. Intuition, direct experience, contemplation. Not because science is wrong, but because science is a specific method designed to answer specific types of questions. And some questions fall outside its domain. What is the meaning of life? Why does anything exist rather than nothing? What is consciousness? These aren't scientific questions. Science can study correlates. Brain activity associated with consciousness. Evolutionary advantages of self-awareness. But it can't tell you what it is to be you. That's a different type of knowing. And Oppenheimer realized that physics, for all its success, is hitting limits where it can't go further without confronting these deeper questions about observation and consciousness and reality itself. So here's what this all means, and why Oppenheimer's realization about limits should change how you see everything. The universe isn't ultimately knowable. Not fully. Not in the way we'd like. We can build models, make predictions, develop technologies. But we're always working with shadows on the cave wall. representations of reality filtered through our sensory apparatus and cognitive limitations. When Oppenheimer looked at the atom, when he calculated how nuclei behave and particles interact, he saw the math, beautiful, elegant equations. But he also saw the limit, the point where equations stop corresponding to anything you can visualize or comprehend, where you're just manipulating symbols according to rules and trusting that the results mean something even though you don't understand what. And that's where we are. That's where physics has been since quantum mechanics. We have tools that work, math that predicts, but we've lost the comfort of understanding, of knowing what's real. The Copenhagen interpretation says particles aren't real until measured. Many worlds says everything that can happen does happen in parallel universes. Pilot waves say there's hidden structure we can't detect. And the universe doesn't care which story you prefer. All that matters is whether your predictions match experiments. Truth becomes operational rather than ontological. And Oppenheimer found that deeply unsettling. He wanted to know what was real, not just what we measure. And physics couldn't give him that anymore. It had reached a limit, maybe temporary, maybe permanent, but a limit nonetheless. Can you accept that? Can you live with a universe that might be fundamentally beyond human comprehension? Where the deepest truths might be inaccessible to minds like ours? If this exploration of the limits of knowledge changed how you see science and reality, hit that like button. And if you want to keep diving into what physics can and can't tell us about existence, subscribe and turn on notifications. Comment which limit bothers you most. And before we go further, let me tell you about another limit Oppenheimer discovered that's even more disturbing. He realized that language itself is a barrier. Every word we use to describe physics was invented to describe everyday human-scale experiences. Particle means a tiny, solid thing. Wave means something that ripples through a medium. Position means where something is in space. Time means the forward flow of moments. But in quantum mechanics, none of these words mean what they normally mean. An electron isn't a particle in the everyday sense. It's not a little ball. It's not a wave in the water sense. It's not rippling through anything. It's something completely different that behaves particle-like in some experiments and wave-like in others. And we're stuck calling it a wave particle because we don't have a word for what it actually is. Our language evolved to describe trees and rocks and animals. Not quantum fields, not curved space-time, not 11-dimensional membranes. So when physicists talk about these things, they're using words metaphorically, stretching language past its breaking point. And that creates confusion, not just for regular people learning physics, but for the physicists themselves. Because if you can't name something properly, if you can't describe it in language that maps onto concepts in your brain, you can't fully think about it. You're limited by your linguistic categories. Oppenheimer was fluent in 8 languages. He read Sanskrit so he could read the Bhagavad Gita in the original. And he became obsessed with how different languages carved up reality differently. How Sanskrit had concepts that didn't translate cleanly into English. How the structure of language shapes what you can think. And he realized that all human languages might be fundamentally inadequate for describing quantum reality. Because quantum reality doesn't work like anything in human experience. There's nothing in the macroscopic world that behaves like a superposition. Nothing that exists in multiple contradictory states until observed. So we have no words for it. We fake it with math. And the math works. But the understanding, the deep gut-level comprehension, never comes. Because we're using the wrong conceptual tools. We're trying to paint with hammers, build houses with paintbrushes. The tools don't match the task. And that's a limit, a hard limit on what humans can know. Think about this carefully because it gets at something profound. Every scientific theory is a model, a simplified representation of reality. Newton's laws model motion by treating objects as point masses. It ignores air resistance and friction, and the fact that solid objects are mostly empty space filled with quantum probability clouds. But the model works for cannonballs and planets. General relativity models gravity as curved spacetime. It ignores quantum effects, but it works for stars and galaxies and GPS satellites. Quantum field theory models particles as excitations in fields. It ignores gravity, but it works for particle physics and chemistry. Every model has a domain of applicability, a range where it gives good predictions. And outside that range, it breaks down. You can't use Newtonian mechanics at 99% the speed of light. You can't use general relativity inside an atomic nucleus. You can't use quantum mechanics to predict the orbit of Jupiter. Each model has limits. And here's what Oppenheimer realized. Maybe reality itself is too complex, too multifaceted, too high-dimensional for any single human comprehensible theory to capture it all. Maybe the dream of a theory of everything, one elegant equation that explains all of physics, is impossible. Not because nature is fundamentally disunified, but because human brains can't hold that much complexity in a comprehensible form. We'd need a brain the size of a galaxy to visualize 11-dimensional Calabi-Yau manifolds. We'd need cognitive processes we don't possess to intuitively grasp how quantum mechanics and general relativity unify at the Planck scale. The theory might exist mathematically. We might even discover the equations someday. But understanding what those equations mean, actually comprehending the reality they describe, that might be forever beyond us. Like expecting a dog to understand calculus. The theory exists. The math is real. But the dog's brain can't process it. And maybe we're the dogs looking at quantum gravity. We can write the symbols, but we can't know what they mean. Now let me tell you what happened to Oppenheimer that made these limits personal and painful instead of just abstract philosophy. During World War II, he led the Manhattan Project. Thousands of scientists and engineers working to build the first atomic bomb. And Oppenheimer was brilliant at it. He understood the physics better than almost anyone. He could calculate critical masses, design implosion lenses, predict yields. The math worked. The bomb worked. On July 16, 1945, at 5:29 in the morning in the New Mexico desert, they tested it. The Trinity test. And it was more powerful than most people expected. The fireball was brighter than the sun. The shock wave rattled windows over 100 miles away. The mushroom cloud rose 7 miles high. Oppenheimer watched it happen. He'd spent 3 years calculating and predicting and engineering this moment. And when he saw it, really saw what they'd created, he was horrified. Not surprised. He knew the physics. He'd done the math. But seeing it made it real in a way equations never could. And he quoted the Bhagavad Gita. "Now I am become death, the destroyer of worlds." Because he understood something that most people didn't. The bomb wasn't just a weapon. It was proof of a terrifying principle. Humans could understand the physics of the nucleus well enough to release its energy. But we didn't understand ourselves well enough to be trusted with that power. We'd hit a limit. Not a limit in physics. A limit in wisdom, in maturity, in our ability to handle knowledge responsibly. And that limit might kill us. Within weeks, the United States dropped atomic bombs on Hiroshima and Nagasaki. Roughly 200,000 people died, most of them instantly vaporized or burned alive. And Oppenheimer felt responsible. Not legally, Not solely, but morally. He'd helped build the weapon. He'd solved the physics problems. He'd made it possible. And he spent the rest of his life wrestling with that, with the knowledge that physics doesn't care about human welfare. It's just equations, neutral, amoral. But humans aren't neutral. We're tribal, violent, short-sighted, and giving us godlike power over matter and energy without corresponding wisdom is catastrophically dangerous. He said later, "The physicists have known sin, and this is a knowledge which they cannot lose." He wasn't talking about religious sin. He was talking about the burden of knowledge, of understanding things that can't be unlearned, of seeing limits and realizing that approaching them has consequences, moral consequences, existential consequences, the limit of human wisdom compared to human power. And we crossed it, and we're still living with the consequences. Let me tell you about one more limit that Oppenheimer discovered, and this one might be the most fundamental of all. It's the limit of certainty. In classical physics, in Newton's world, if you knew the position and velocity of every particle in the universe, you could, in principle, predict the future perfectly. The universe was deterministic, a clockwork, wound up at the Big Bang and ticking forward according to fixed laws. But quantum mechanics destroyed that. Heisenberg's uncertainty principle says you can't know both position and momentum with perfect precision simultaneously. The product of the uncertainties has a minimum value. And it's not because our instruments aren't good enough. It's fundamental, built into nature. The electron doesn't have an exact position and exact momentum at the same time. Those properties don't exist simultaneously with infinite precision. And that means the universe is fundamentally probabilistic, not deterministic. You can calculate the probability of an electron being here or there, but you can't say with certainty where it will be. You can only say where it might be and how likely each location is. And when you measure it, when you collapse the wave function, you get one result. But you couldn't have predicted which result. It's random, truly random. Not pseudo-random like a computer algorithm. Not deterministically chaotic like weather. Actually, fundamentally unpredictable in principle. And Oppenheimer understood what this meant. It meant the universe has built-in uncertainty. Knowledge has limits that can't be overcome by better technology or cleverer math. Some things are unknowable in principle, and that shattered the dream of complete knowledge, of understanding everything, of perfect prediction. Einstein hated this. He famously said, "God does not play dice with the universe." He thought quantum mechanics must be incomplete, that there must be hidden variables we haven't discovered yet that would restore determinism. But tests have shown he was wrong. Bell's theorem and experimental violations of Bell's inequalities prove that no hidden variable theory can reproduce quantum mechanics without allowing faster-than-light influences. The universe really is probabilistic. Reality really does have irreducible uncertainty. And that's a limit we can never cross. We can never achieve perfect knowledge, perfect prediction, perfect control. The universe forbids it. And here's why this matters for you personally, and why Oppenheimer's discoveries about limits should change how you live. You exist in a universe that's fundamentally uncertain, fundamentally beyond complete human comprehension, fundamentally probabilistic rather than deterministic. And that means you can't ever be completely certain about anything. Not about the future, not about the past, not even about what's real right now. Your senses filter reality. Your brain constructs a model of the world from limited sensory data. Your consciousness emerges from quantum processes that are inherently probabilistic. You're not perceiving reality directly. You're perceiving a representation, a model. a story your brain tells itself. And that story is useful for survival, for navigating the world, for making decisions. But it's not the territory. It's a map. And the map is always incomplete, always approximate, always limited by the resolution of your senses and the processing power of your brain. Oppenheimer understood this. He understood that being human means living with uncertainty, with incomplete knowledge, with questions that don't have answers. And he found that both terrifying and liberating. Terrifying because it means you're never on solid ground. You can never be completely sure. You're always working with probabilities and best guesses. But liberating because it means there's always more to discover, always deeper questions to ask, always mystery at the heart of existence. The universe isn't a solved puzzle. It's an infinite game. And the limits aren't walls stopping you from playing. They're rules defining how the game works. You can't know everything, but you can keep learning, keep exploring, keep pushing against the boundaries, knowing you'll never reach the edge, because there is no edge. Just deeper and deeper layers of reality that might be forever beyond human comprehension, but are endlessly fascinating to explore. So what do you do with this knowledge? How do you live in a universe with limits? Oppenheimer's answer evolved over his lifetime. Early on, he threw himself into physics, trying to push the boundaries, understand the atom, calculate the uncalculable. After the bomb, after seeing the consequences of knowledge without wisdom, he became more cautious, more philosophical. He served on government committees trying to control nuclear weapons. He opposed the hydrogen bomb. He argued for international cooperation and arms control. And he was punished for it. In 1954, during the McCarthy era, he was hauled before a security hearing, accused of being a communist sympathizer. His security clearance was revoked. His career was destroyed. And he spent his final years teaching, thinking, writing about the relationship between science and society, about the limits of knowledge, about the responsibilities that come with understanding. He died in 1967 from throat cancer, probably caused by the chain smoking that started during the intense pressure of the Manhattan Project. And his last years were spent grappling with the same questions. What are the limits of human knowledge? What should we do with the knowledge we have? How do we live with uncertainty? And he never found definitive answers, because those questions don't have definitive answers. They're the kind of questions you live with, that shape how you see the world, that remind you that being human means accepting limits while still striving to understand. It means holding two contradictory truths simultaneously. We can't know everything, and we should keep trying to learn. The universe is beyond us, and we're part of it. We're limited, and we're limitless. And maybe that paradox, that tension between our limits and our aspirations, is what makes us human. If this journey into the limits of knowledge and understanding changed how you see science and reality and your own place in the universe, hit that like button to let me know. And if you want to keep exploring these deep questions about what we can and can't know, what physics tells us and what it can't tell us, subscribe and turn on the bell. Drop a comment telling me which limit bothers you most or which one you find most beautiful. The uncertainty principle, the incompleteness of theories, the limits of language, the gap between knowledge and wisdom. Let me know what you're thinking. Thanks for watching.